Hi there, and welcome to PodRocket. I'm Paul, and I'm very excited to have André Kohn with us today. Hi, André. How you doing?
Great. Thank you so much for having me.
Thanks for coming on. I mean, we're going to talk about WebAssembly today. We're going to talk about DuckDB. These are all really exciting things because I feel like WebAssembly isn't talked about a lot on like internet media that I might find on YouTube and stuff. So this is going to be an exciting delve into what's coming with, what we know is the most common development and content platform in the world. André is from the Technical University of Munich. Before the podcast, he wanted to make sure that, we're saying of Munich because that's the correct way to pronounce it. And he's from the database group over there. So you're doing your Ph.D. right now.
Yes.
And so your PhD is in databases, right?
Yes.
That's the general topic. Is it good? Have you enjoyed it?
Yeah, so far it was a fun ride. I mean, I started my PhD 4 years ago. And we have a database here that we developed, which is called Hyper, and the successor to Hyper being Umbra, which is very fast, and it's quite interesting to work on these projects. But last year I took a side turn and explored WebAssembly a little bit. I came in touch with the founders of DuckDB, Hannes and Mark, and we came up with DuckDB-Wasm, which turned out to be a quite exciting project.
Right. So databases are, there's like such a breadth of the types of use case applications out there. And before we get into, the main topic of the podcast, which is DuckDB and WebAssembly, I'd love to just take a quick excursion and ask for my own selfish interest here. Like, what are some examples about the different types of problems that you maybe need to think about as a database scientist? Because, there's like all these terms that we have data lakes, we have like columnar monsters for aggregations. And I know there's like these different use cases and stuff. And I was wondering if you could just speak a little bit on, the breadth of use cases and implementations, because I feel like that matters a lot, right? So
the database landscape is very wide. As you said, there are very many systems for very many use cases. But usually, like the blunt answer is there is not one system that defeats every or is good at every situation, which means that there are these sweet spots for the different systems where they are fast, and then there are situations where are not the best. And interestingly, the database that we talk about today, DuckDB, is in a sweet spot where not too many systems are. It is an in-process analytical and relational database system. And the keyword here that you can focus on a little bit is in process, because in contrast to many systems out there, you can just use it more or less as a query engine if you want. So like a large user group of DuckDB is just, for instance, in the Python world, where you just spin up your Python script, have pip install DuckDB, and then you can just go from there, querying with SQL, whatever data you have, right? This convenience is something that is a very strong argument for DuckDB, because existing systems usually ask you to install something, have a server running, things like that. So DuckDB focuses on very fast analytics in situations where you want to be ad hoc or embedded, situations where you don't want to have the hassle dealing with the server. You can use it as
that's
server.
What in process means. It means It's like it's in the Python process. Can I think about it that way? Or
So okay. If you would just
in memory,
the interesting, no, it's not only in memory. I mean, it is in memory, but you can also use it out of core.
Gotcha.
So with writing to disk. But the key difference is, if you have like a Python script and you want to use DuckDB, you can just use it as if it was a Python library. So it feels very integrated into your program. Whereas if you have an external database, let's say Postgres or so, you would set up Postgres, you would connect against or to Postgres, and then fire some SQL queries against Postgres. The big difference here is that like the approachability of this whole concept is very, very strong, because if you want to use DuckDB in your script, you can just, without much setup, take it from there.
So you can use it as a library. Now, when you say that, does that mean I'm going to get tab completion in my code editor? Or when you say I can use it as a library, is it more like we're talking lower level?
No, no. I'm talking about if you have, for instance, in your process, your data sitting, for instance, in your pandas frame or so, and you want to like pandas is very widely used in Python, for instance. If you just want to query this existing data, the you don't need to ship your data somewhere else, but you can just use DuckDB to consume the data that you already have, which is A, faster, and B, more convenient if you just want to get your answers for your analytical queries.
And is the in process kind of benefit here the speed up? Because is one of those things I'm just thinking lower level because, oh, we don't need a, there's no inter-process communication, there's no network communication, there's no like paging as heavily in different sectors of memory on the CPU level and on
Mm-hmm.
disk. Okay, so it's like we're getting all these benefits into
Yes.
the
So of
in-process.
course,
Okay,
with the
gotcha.
convenience, like the second big point is, of course, if you have your data sitting in your process, you don't need to spend time shipping it over the wire to or over a domain socket or whatever communication you use
Because
to
a
your
socket
database.
has latency, right, as well.
Yes. Yes.
And I
Yes.
feel like usually as, a higher level programmer myself, I think of a socket, I'm like, oh, it's like I'm talking to the other guy in the room. He's right there, but there's something to be realized there if we're doing massive volumes of work. Gotcha. Great. So, all right, we got a little bit of database speak in here before we talk about, really what you're focusing on, which is bringing DuckDB into WebAssembly, right? And exposing it to a bunch more use cases all over the place. So, do you want to maybe start off of talking a little bit about how you got started with the project and what is WebAssembly for people that are just stepping into it?
Mm-hmm. Mm-hmm. So, as I said earlier, like my PhD actually is not like with the CWI people who invented DuckDB. Instead, we are developing a main memory engine called Hyper and Umbra. But the big upside or the big advantage of DuckDB is that it is more or less self-contained. So, with WebAssembly being or becoming more and more popular, um, I got excited about the fact that you could pick this fast analytical database and bring it to WebAssembly without dealing with very many problems that you would have to solve with a database that is more complex. So for instance, Hyper and Umbra depend on libraries that are very large, and porting them to WebAssembly would be a lot of work. And with DuckDB, it was a lot easier. So how did I get to WebAssembly in the first place? Well, it started as a side project. So I had a pet peeve, you could say. I was like when COVID started, like what you saw very often was these rather simple dashboards, and you would see loading spinners all over the place, right? Yeah, exactly. And you had loading spinners all over the place initially, because usually in the world where you have analytics servers presenting analytical data to users, you would have a server like doing the processing and then the front end doing just more or less the dump rendering of the results. And this turns out to be a large bottleneck, right? Especially if you in the COVID situation, we had this where like 10,000s or even more users need to, or want to look at a dashboard very frequently, and then you just are left with the question: how do you scale up? How do you like throw hardware at the problem? How can you like get the request being answered quickly, right? So this is a problem, and I was a little bit surprised that it is for these scenarios surprisingly hard to do all the analytical processing within the browser itself. So the analytical questions that you ask in these scenarios are rather simple, right? The problem is that JavaScript is not really well equipped to do analytics. So JavaScript is, even though it is of course a very flexible and dynamic and very widespread language, it's not the most efficient one. And if you want to crunch data or do more complex joins, JavaScript is just not the right tool for the task. So
Sorry if I may interject for a second. When you're talking about processing with JavaScript, we're saying, all right, and in this example that we're talking about in the
yeah,
back end, it's JavaScript grabbing this data, grabbing that data,
yeah,
combining, aggregating, summing, making our
yeah.
lines. Okay, gotcha.
Yeah, exactly. So these are tasks that databases do all the time, right? So you just fire your SQL query against your database of choice, and what the database internally will do, it will join the like the rows using hash tables and aggregating them and so on. Of course, you can do this in JavaScript as well, but JavaScript is just not the right fit. It's just too slow. So with WebAssembly, this picture shifts a little bit or changes a little bit because WebAssembly is quite fast. So if you bring a database to WebAssembly, my hopes were that you can get fast analytical processing in the front end and thus in many cases just eliminate the central analytics server. So in these situations, you would just serve the very same dashboard. For the user, it would be the exactly same like output, but you no longer have a server processing in the background that you need to scale, but instead everything is computed in the front end. Of course, this has implications. This is not working for every situation, but the cool thing is that this was let's say, a first stepping stone towards an area that you could explore, because with the browser or front end being more powerful, you can build much more exciting things, right? The cool thing is that this data processing becomes more of a tandem operation. You have in the front end, you have analytical processing power, you have in the back end analytical processing power, and then your decision where you do work is more or less dependent on what's your optimization target. If the big strength of doing things in the front end is latency. If you just want to have, let's say, a filter in your dashboard, and you just have your snappy interface, like giving you the new range, you can decide whether if you want to just send it to some remote server, which will immediately bring up the cost of the round trip to the server, or you do it in the browser and you have immediately your snappy result. So the difference there is very, very surprisingly cool. So if you have that once, it really feels very snappy to have the processing done in the browser.
So how is this different? I guess if I had a dashboard and I said, all right, I want to display all the COVID data from Massachusetts, I brought it all in, and I had God, I don't know, like a 30 or 50 megabyte array of numbers in memory. Right now, that JavaScript is, I feel like I'm pretty good at slicing that with a JavaScript and pretty good at combining it, and it's pretty snappy. But what we're talking about is like on another level, right? We're talking about intense processing in joins that need a database engine, but you don't, but we're bringing it to the front. Is that kind of where this
Yeah,
fits?
there are two points here that I want to make. Of course, I totally agree with you. Like scanning through 30 megabytes of rows, even in JavaScript, is not a terribly expensive operation. But there are two sides to it. First, usually, like of course, if you just compute a single sum or a count or so, or minimum, maximum, blah blah blah, this is simple. You just even to write this in code, this is in JavaScript just usually a single loop. You just compute something. This is easily done. But let's imagine you have three or four of these 30 megabyte sets of rows, and you just decide, I want to join my COVID data with the states, and then find something out over the course of a certain time range, and then join this with population or like age range or so. These kinds of parameters like immediately bring up the question: how do you evaluate joins efficiently? And then like this is a business where databases are already very, very good at. And if you just do it by hand in JavaScript, you will end up A, being slower, and B, being probably not optimal. Like is this for instance, evaluating joins is a very well explored problem in the database community, which has many um, rabbit holes if you just want to try to build this yourself. I mean, I can almost guarantee you, if you just like write this naively, you will end up with an implementation that is not the optimal one. And but yeah, this is nothing you actually have to worry about, right? Especially if you know SQL. Like, this is the second point that I wanted to talk about. If you know SQL, you don't need to write a for loop over your 30 megabytes at all, right? So you just load your data in your database, and then you just write your SQL query, and the database takes care of everything else. So it's not only about the fact that you uh, are efficient when processing, but it's also the convenience to just use the querying language that you are uh, that many are familiar with.
Right. That's widespread and well
Yeah,
known. Right. Okay. So that totally makes sense. And we're taking this and in the COVID example, I guess, one possible there's a bunch of ways you could do this, but one possible architecture is you're running WebAssembly, DuckDB, you bring in the data, you load it live on that very, loading of the web page, and then you can query that database to populate your graphs very quickly. Um, Conversely, could you have a web page with DuckDB, that stores something in the local browser memory or cache, and then you load that up and it's already there, sort of.
yeah.
Cool. Okay.
I mean, we are exploring this quite a bit at the moment. Of course, this is something like local persistency in the browser is a difficult topic. I mean, usually people have something like IndexedDB that they use, which is not really fast. But there are scenarios that we could focus on in the future, which would, for instance, allow us to just have a locally persistent version of DuckDB that would behave just like a normal database. This is for some reasons that are out of reach for us, not working today. Like, for instance, the browser APIs are a little bit evolving at the moment. What we would need is a local file system access that is fully synchronous. This like there is a current origin trial in Chrome that allows us or gives us synchronous file system access, but unfortunately the authors decided to have two calls in there being asynchronous, truncation for instance being one. And yeah, this hinders us at the moment to like go fully the native persistency route, but this is something we want to explore in the future. I wouldn't consider this to be like especially today, not the main selling point of DuckDB-Wasm, but this is a very exciting opportunity for the future. If we are able to get it fully persistent locally, you would get IndexedDB on steroids with DuckDB-Wasm without, yeah, I mean, it is like that, right? So you have just your local database, like writing to your local browser file system, and then whenever you visit the website again, you can just pick the data up that you left and just consume it with SQL, as you are used with. Like, native applications on mobile devices do this for ages, right? But
Right.
in the
Right.
browser, you are usually very limited in what you can do. So yeah, this could be quite
That
exciting.
could be very exciting. I mean, that could totally change the way we think about websites.
Also, like, let me just get one additional thing out. One strong point for DuckDB-Wasm that we focused on is consuming data partially. So, like, one thing, if you have a website and you have, for instance, on AWS S3 or so, your CSV or Parquet files sitting, and you want to query them, the classical stack or architecture how you would build this is that your JavaScript application would load the data into the browser and then do whatever you want to do with it. But databases traditionally are quite strong at just picking up those parts of the file that you are interested in, right? So if you only read a subset of the columns within a Parquet file, or Parquet is a format that is also structured in, they call it row groups, you are only interested in a certain part of the Parquet file because, for instance, it's ordered by time and you are only interested in, let's say, the last 10,000 entries in there, then DuckDB-Wasm will be able to query these files and read only the parts that qualify, which is cool because then you can have your remote file being 1 gigabyte large, but the relevant data for your browser relevant query is in the order of, let's say, 10 to 20 megabyte or so, which will be then in a manageable area.
And that's critical if you want it on the client side browser, because you
Yeah.
could really have performance capabilities and hardwares that's down in the dumps, for
Yes.
lack of a better phrase, and you want it to work for as many people as possible,
Yeah.
right?
Exactly. I mean, this also blends into what I said earlier with the tandem between the browser and server side processing. Like, I believe one very exciting use case for DuckDB-Wasm is not to fully replace the server, but just work together with a server side database to improve latency and scalability of the system. Because if you like, this is something we will be able to help users as well, but with let's say a more distributed query optimization that spans across multiple nodes. But the architecture in the future could just look like you have your local browser-sided database, you have your server-sided database, and then you answer queries with the lowest possible latency based on where the data sits. So if you spend, for instance, the time already to download a subset of the data, you can just filter it very instantly or almost instantly with the browser-based database. And then if you just want to query this gigabyte slash terabyte large data sitting somewhere in the cloud, then of course it won't be an option to download it to the browser. Then you use the server sided version. So this tandem uh, could like lead to very interesting new ways how you design these applications that would get rid of very many loading spinners today. Yeah.
I know I've used D3 before for massive data sets, and it's done a pretty good job, but that's only on some data. Like, this is going to open up data, every type of data, every type of bit and byte that you can store. And D3 is definitely, it has its use cases. So maybe those people who did the spinners maybe should have checked out some of the new capabilities of D3.
It's interesting that you mentioned that. Like, I'm or we developed DuckDB-Wasm together with a professor at the CMU, Dominic Moritz, who is the author of Vega. Do you know Vega?
I,
Vega is a visualization framework which is based on D3. And the cool thing there is that it, for instance, talks arrow, and we can just feed or integrate DuckDB-Wasm rather easily into Vega to just like display whatever data you want to display, which allows you to just formulate your data processing with SQL instead of the Vega transforms, and then let Vega do the visualization business with displaying your
which
charts and so
sounds
on.
how it should be. It's
Yeah,
compartmentalized, and the things that are good at what they do are doing the things at what they're good at.
yeah,
So, um, I would love to take a little excursion also off the database. I mean, we could still we'll probably get back into it, but about WebAssembly specifically. So, what is it? It's this new sort of like compiled assembly language that runs in the browser. But I was wondering if you could, enlighten us a little bit more about some of its capabilities, maybe some of its downfalls. Because every time I hear about something that's running some new feature in the browser, I'm like, all right, who's gonna hack it first? Like, what are they gonna find? How are they gonna? What's the new way they're gonna control my computer if it's not Flash games?
hmm
So I wonder
so
about the security as well.
yeah, so WebAssembly is very interesting because it's a binary instruction format in the first place that all browser vendors pretty much agreed on to implement, right? So this in the browser world, you also or always have the problem that you need to find the common denominator between all these different use cases, right? So which is why JavaScript won't disappear for a very, very, very long time, because everyone started using JavaScript, everyone can speak JavaScript. This is a very excellent language for the purpose of being platform independent. But the problem that I mentioned earlier already is JavaScript is slow. So with that having said, like, WebAssembly is the answer to JavaScript being slow. It's just a instruction format that is spoken by all the major browser platforms, plus a few native runtimes already. And it can be compiled to machine code very, very efficiently. It is conceptually, it's a stack-based virtual machine, but you can lower it to machine code very good. And this allows browsers to get to near native speeds. It is also secure. So if you WebAssembly is designed in a way that, for instance, memory won't like shoot you into the foot. Like if you take a C++ program and you just let the user write whatever he wants to, right? This would be a very dangerous endeavor to run this code in your browser, right? If you don't trust it. But the WebAssembly folks have done a good job, like keeping this isolated and safe. And this gives you just a near native speed at with the security of a browser sandbox, which makes it the ideal target for higher level languages like C++ to compile to it. So DuckDB is written in C++. We compile to WebAssembly and then just rely on the browser to uh, get this up to speed as much as it can. And the very interesting aspect here is that the Chrome developers, for instance, behind V8, developed a compiler called Liftoff, and Chrome is insanely good at executing WebAssembly. So I once visited a talk here in Munich of the Liftoff people, and they talked a little bit about how they compile WebAssembly, and it was amazing. So, for instance, they have this very quick first compilation, then upgrade to a more like higher quality compilation output later when they see that your code is hot and so on. So these things are insanely complicated to build, but your browser just gives it to you. All you need to do is just compile your code in whatever language you want to write it to WebAssembly, and then just throw it into the browser and let the browser do the rest, which is of course amazing. I mean, this brings us to speeds that haven't been seen in the browser before, and combined with the focus on analytical processing of DuckDB, we can evaluate evaluate analytical queries very efficiently in which hasn't been done before. There is a WebAssembly version of SQLite, for instance, which is another database that is not tailored towards analytics specifically, but they are already in or they also use WebAssembly to evaluate queries. And it's very exciting how this space is evolving. So now you have the very different choices starting to emerge in the browser space, and you no longer need to resort to JavaScript for things that are probably better done in a database.
So do you think any application that, has any sort of processing could benefit from looking at WebAssembly? And I'm thinking, like, right now we're on a high definition video chat software. Like that, that's something that it's maybe not completely database related, but is this something that could benefit a type of application that maybe is a good target for somebody to think about writing in WebAssembly, or is that off center here?
So one thing that cycling back to the Chrome developers, like this always strikes me, like they did an excellent job to get JavaScript up to speed, right? So right now we are looking at performances of JavaScript, even if you're or even with JavaScript being such a dynamic and flexible language. They did a pretty good job at executing this JavaScript code very efficiently. That means that for many use cases, JavaScript will just be perfectly fine. So right now, WebAssembly is still very young, which means that you are fighting very many like childhood problems of WebAssembly still. And in the meantime, if you would have just picked JavaScript, it would have done the job almost as good as with WebAssembly, and then you would have been already done with the task. So JavaScript is still a very solid choice. Also, like one thing that WebAssembly cannot do very well is interacting, for instance, with the DOM. So if you have your document object model of your website and you just want to have, for instance, React representing your website state, this is nothing you would today do with WebAssembly. So in all these cases where you, for instance, want to react to a user event or things like this, WebAssembly is just not the right fit today. So for the question whether you should use WebAssembly, usually I think if you are processing a lot of data usually, then WebAssembly is probably something you could consider with something like DuckDB-Wasm. For cases where you are not processing bound, I would probably not use it today unless you want to unify your stack, right? There are these projects like in the .NET world, Blazor, where you can just basically write ASP.NET code and just run it in your browser, right? Um, these things are an upside because you can just have the almost the same code base and run it over on the client side. But this is not an argument more anymore about performance, right? This is more an argument about convenience then. And I at least see the near term and midterm future of WebAssembly being more an accelerator. So you have cases that benefit from a better processing efficiency. Then you write your the main application still in JavaScript with React or whatever framework you choose. And then you just, for these performance sensitive things, you glue your database or your WebAssembly code to your application.
So right now it's very much in the phase of like it works and it has, very tangible benefits, but how realistic is it to use it? It's in certain very specific use cases right now that relate to maybe processing. And because, yeah, JavaScript is so mature at this point. And like you said, I've watched other YouTube videos of, conferences and stuff of people talking about, well, we had this problem, but the Chrome guys just solved it by making JavaScript faster again. So, that's where they just keep doing a very good job at making it JavaScript faster. So,
Yeah, usually today, like more and more things are about data, right? So even if you like just pick our use case of like accelerating analytical processing in the browser, this already touches a very large variety of use cases, right? So probably with data being like ever more present and more relevant to users, um, the data processing alone is a very strong argument probably to consider sooner or later using DuckDB-Wasm or like a database in WebAssembly, whatever it will be, um, because this is still something that we are good at. But yeah, as you said, for if you have just an application or a CRM tool or whatever, like um, a very complex interface where you need to guide users and so on. This is nothing that where you would benefit from WebAssembly immediately.
gotcha. And one last thing about the WebAssembly, just as a topic in general, it's a standardized, you know, compiled language by which like these engines can run code and run, as you said, is at near native speeds. That's a big thing for like a language like Go, where you can write something and it runs everywhere. Do you think that WebAssembly is going to start stepping into that role in any way of being just a common runtime that people are just going to use to perform the work that they need to do?
Yeah, it's interesting that you focused on runtime. One thing that strikes me as a very interesting future environment where WebAssembly will have a deep impact is actually function as a service. So if you look at, for instance, Cloudflare functions, I'm not quite sure
Hmm.
whether you've
Or
seen.
workers,
Yeah, sorry, Cloudflare Workers and
right?
Netlify also has an offering. They what they do instead of, or in contrast to AWS Lambdas, they don't like they use just WebAssembly and JavaScript to build function as a service in a very cheap way. So there is a cool article about how Cloudflare workers internally work. What they basically do is, while you do your HTTP handshake with Cloudflare, they already prepare your function to be executed. And then when the HTTP handshake is done, they are ready. So which basically eliminates this cold start problem
Right.
that you have with AWS Lambda. And the interesting aspect of this is, if you have WebAssembly sitting in this stack, you get near native execution speeds with the flexibility of the like isolation of V8 in these edge functions. So these edge functions work that way because you don't need a virtual machine to isolate your tenants and so on.
Mm-hmm.
They are very snappy and can start up very quickly because you just run them over your V8, right? And the with WebAssembly being in the stack, you get the luxury of these very fast and cheap functions at near native speed,
So it's like V8
which
VMs.
yeah.
Right.
So
Okay.
these Cloudflare workers are quite interesting. Of course, this is still also very young, so this is nothing we have explored excessively today. But I totally see that running SQLite or DuckDB-Wasm in there is a huge opportunity, because then you just introduce another layer towards your data sitting in S3
Closer. Right.
that can scale much easier, or much better when answering your SQL queries at a lower price. So you could, for instance, cycling back to this tandem thing, if you have your processing in your browser, you're processing on your nifty backend server, and you have your processing on your in your edge servers in between in the function as a service, you could just decide, I do my processing there, like the closest to the user, but the closest to the data necessary in terms of downloading performance or bandwidth speeds. So, for instance, if you can't afford to ship the data to the user, maybe you can afford to just ship it to the edge worker and don't need to pay the price for the larger VM sitting in the background.
Right.
So this multi-tier processing is actually, I think, a quite exciting opportunity for an embedded or in-process analytical database, because it allows you to just run complex SQL queries on all of these layers. Yeah.
So let's hope Cloudflare puts that in because
Yeah, we looked at Cloudflare workers more closely, actually, and one downside is they currently implement the service worker API, which doesn't allow us to
mhm,
implement these remote synchronous fetches that we talked about before, like
mhm,
this file system. We built on top of a file system that would partially read remote files, and right now we can't do this in the current version of Cloudflare workers. But I hope, or I'm cautiously optimistic that this will at some point be ruled out or sorted out, and then yeah, we are happy to work with them. This would be quite nice.
that would be cool. As a user of Cloudflare workers myself, that would be. I love to just dump my computational needs on them. I don't know. Do they just make it really easy? If there's simple aggregations and transformations, put it close to your customer.
Yes, totally. And the
It's
costs are so small, right? So they are
it's
very
minuscule.
cheap. Yeah,
Yeah.
yeah.
It's like they definitely did something special, taking from the Lambda people and making something novel. Anyway, we're coming up on time here, Andre. Before we, go through our closing ceremonies here, is there anything that you would like to link to our listeners, point them to people you want to shout out at?
So yeah, I would love to just mention Mark and Hannes, who have been very generous and very exciting to work with. So of course I'm working remotely with them, which was a quite interesting endeavor. And those two have very big plans for DuckDB, and I hope for the best for them. So they have this company called DuckDB Labs, which is doing support contracts. So if you are interested in DuckDB, or DuckDB-Wasm, like this is the best point to start. Just chat with them and approach us. We have a Discord server, and
Oh,
if
so we can
you,
link that for sure
yeah,
if you
cool.
pass us. Yeah.
If you have anything coming up with DuckDB or DuckDB-Wasm, just ping us there, and we are happy to talk. So yeah, thanks
All right. Yeah.
for the time.
Thank you for being on the show, Andre. And hopefully some people will start looking into WebAssembly and these new kind of website architectures that are going to shape tomorrow. So
Cool.
thanks for
Thanks.
coming on.